Good morning to all. In this today's class, we are going to discussing about the Borata model. In this Borata model, he explains about the stability of the atom and also explains about the line spectrum that can be observed for a hydrogen atom. So he also explains what are the advantages of this Borata model is. The electron can in an atom moves around the nucleus in circular orbit. It undergoes two forces, that is Coulomb electrostatic force of attraction and also for centripetal force of that can be produced for an electron in a circular motion. And also the atom revolves around the nucleus only in a certain discrete amount of called the stationary orbits. So the angular momentum of the electron in this stationary orbits are quantized, that can be equal to that is L is equal to n h bar. So n is the principal quantum number and also h bar is known as the multiple of, that is h by 2 pi. So that is called reduced Planck's constant. So where L is equal to nh is the condition for the angular momentum quantization condition. According to the quantum mechanics, the electrons have the dual nature because the standing wave pattern of the de Broglie associated with orbiting electron. So that is in a stable orbit. So here r is the radius of the circumference of the electrons which can be revolving around in a circular form, and here the one wave, complete wave is called the wavelength, that is lambda here. So it can be associated with the circumference of the electron orbit of radius r must be an integral multiple of the de Broglie wavelength. So here 2 pi r is equal to n lambda. So n is the integer, so that is a natural number, that is 1, 2, 3. That is also the length 2 pi r is equal to n lambda. So but the de Broglie wavelength lambda associated with the electron of mass m moving with the velocity, so that can be equal to lambda is equal to h by mv. So here h is called the Planck's constant. From this equation, substitute in this above equation, 2 pi r is equal to nh by mv. So rearrange that above equation, mvr is equal to nh by 2 pi. So this is the value, and you know that L is equal to nh bar. So L is equal to or mv. So mvr is also equal to L, that is called nh bar. So this is the values that can be associated with undergoing the circular motion of with radius r and velocity v. So next one is the energy of the orbits r. So here the energy can be equal to, here delta E is equal to, so this energy levels, the electron in an orbit is not continuous but only discrete. So here the electron can jump from one orbit to another orbit by observing or emitting the photon. So this energy is equal to the difference in energy level between the two orbit levels. So here delta E is equal to E final minus E initial. So that is final energy level minus of initial energy level, that is equal to, you know that E is equal to h nu. So E is equal to h nu. Nu is also equal to c by lambda. So here c is the speed of the light. So the next one is radius of the orbit of the velocity of an electron. So here let us consider the electron. So this is the picture. Let us consider an atom which contains the nucleus at rest and an electron is revolving around the nucleus in a circular orbit. So with the radius of Rn, and the nucleus is made up of the protons and neutrons also. The protons is positively charged and neutrons is neutrally charged. The charge of the nucleus is entirely due to the charge of protons. So here let us assume that the electrostatic attraction provides the centripetal acceleration here. So that gives the centripetal force here, and also the electrostatic attraction forces is also for two charges. So let Z be the atomic number of the atoms, and then positive Ze is the charge of the nucleus. So here minus E be the charge of the electron. So according to the Coulomb's law of force of attraction between the nucleus and the electron, here F value is equal to, so that is 1 by 4 pi epsilon naught plus ZE minus E. So plus ZE is the, so that is Q1, that can be considered as a atomic number of the atom. So sorry, charge of the nucleus. Here minus E refers the charge of the electron here. So that can be equal values. So here Q1 and Q2 values. So divided by Rn square here. So that can be equal to minus 1 by 4 pi epsilon naught ZE square by Rn square. So this is the value of force of attraction, and also this can be equal to the necessary centripetal force value. You know that centripetal force F is equal to mv square by r. So according to that, F vector is equal to mv square mvn square divided by rn. So r cap. So this is the centripetal force value. You have to equate the two values here, and finally you will get Rn value. So we want to find out the Rn value here. So Rn is equal to 4 pi epsilon naught mvn whole square divided by zme square. So this is the Bohr's assumption, that is the angular momentum. So this is the value of the radius of the electron, and also we have to assume that mvr is also equal to L. So L is equal to nh bar. So that can be equal. Substitute that value. So finally you will get Rn is equal to 4 pi epsilon naught. So instead of mvr, you substitute the L value nh bar whole square divided by zme square. So finally you will get the value of 4 pi epsilon naught n square h bar square divided by zme square. So Rn is equal to, so you have to spread out the constant values out, and also n square by z in a separate value. So that can be equal to Rn is equal to z epsilon naught h square divided by pi me square into n square by z. So finally that constant value is equal to a naught. So Rn is equal to a naught n square by z square. A naught value, already you know that all the constant values, that can be equal to 0.529. So next we want to find out the velocity value, velocity of an electron. So according to this Bohr's angular momentum quantization, mvr is equal to, so mv, the r value is a naught n square. So according to this equation, that is also equal to nh by 2 pi. So we want to find out the velocity value. Vn is equal to nh by 2 pi into, so that is a naught n square by m. So finally v value is equal to n by 2 pi m a naught z by n. So here you have to conclude all the constant values in one side, and v is inversely proportional to 1 by n. So here the velocity of the electron decreases as the principal quantum number increases. So this indicates the electron is bound in the nucleus. So this also shows the stability of the electrons here. So the next one, the energy of the electron in an nth orbit. So here we have to, so instead of Q1, Q2, so Q1 plus EZE and also Q2 minus E. So substitute that Q1, Q2 value here, and finally you will get minus 1 by 4 pi 4 epsilon naught square. So Z square m e power 4 divided by h square n square. So this is the value. You substitute the Rn value here. Rn value already we are found out, that is the radius of the electron. So that is the value, you substitute that, and kinetic energy for the nth orbit is of mv square. So in this equation you have to substitute the v value. Then finally, so here the total energy of the nth orbit is, so this potential energy is equal to minus, that is 2 times of kinetic energy. So that can be, that is the total energy is equal to En is equal to kinetic energy plus potential energy. Kinetic energy, potential energy is equal to 2 times of kinetic energy. That is also minus 2 times of kinetic energy. So minus 2 key that is kinetic energy. So that is equal to minus Ke. So finally En is equal to, so that is the minus of kinetic energy value. So this is the energy of an electron.